Talk today about factoring out a greatest common factor. To factor out a GCF, that's what the expression that they use for greatest common factor, is the opposite idea as distribution. Here's a couple of examples of distribution. So this first one, we are distributing a 5 to each piece of the parentheses. To factor, we would look at the 5x and the 30, and we would think about factors that they have in common. Only the first part has the letters x, the second part has no letters, so there will be no letters in common. Next, you look at the coefficients. This is a 5, which 5, it just has factors of 1 and 5. And 30 could have factors of 5 and 6. It has other ways of dividing it as well, but I used the 5 and the 6 because I was wanting to see if they had a 5 in common. And they do, because 30 is divisible by 5. So the greatest common factor for 5 and 30 is the number 5. And so what you do is you divide each piece by 5. Dividing the 5x by 5 would give you x as your remaining amount. Dividing the 30 by 5 will give you 6. So when you're factoring, you take the GCF, you divide each piece by that GCF, you write the GCF in front, and then what you got when you divided is what goes inside of the parentheses, which essentially takes you back to the beginning of that distribution problem. You can check by using distribution to make sure that you did that correctly. Here's another example of just factoring. But here the common factor is a negative 3x. We're going to look at some that we're going to be doing from scratch. Here we have a trinomial. It has 3 pieces, and we're going to be factoring out the GCF. The first step is to think of the factors of each part. So factors of 6 are 2 times 3, and then x squared is like having x times x. For the 2xy, 2 is a prime number, so 2 cannot factor, and then it has an x and a y. And then the last piece here is a 4. 4 has factors of 2 times 2, and then it has an x. So this is the factorization of each term that we see here. Next, I'm going to find the GCF. Each set of factors has a 2 in it, so 2 is part of the GCF. The next thing I'm going to do is look for other numbers. Here I have a 3, but this one only had a 2, and this one has another 2. So they don't have any other numbers in common, just the 2. And they do have some letters in common. They have an x in common. They all have at least one x. So since this one had 2 x's, but neither of the others had an additional x next to it, the most x's we can take out of each piece is 1x. And then the highest number we can divide each piece by is 2. So the GCF is 2x. So the next thing we're going to do is we're going to take each piece. So I'm going to start by just rewriting the pieces here, the terms. And we are going to divide each part by the GCF. And then once we're writing the answer, what we're going to do is we're going to write the GCF in front, and then we're going to have parentheses with each term. And those terms are going to be separated by the sign that is in front of them. Six x squared divided by 2x, and this is why we looked at exponents last week, is because this is like a quotient exponent problem. 6 divided by 2 is 3. You divide your coefficients, and then again, where are there more and how many more? There's more x's on top, there's 1 more on top, so the power on the x is now 1. Next, 2 divided by 2 is 1. You could put the number 1 or just write what we get from our letters here. X divided by x, those cancel, so the 2 is reduced and gives you 1 over 1. The x is reduced and gives you 1 over 1. And then you just have the y left. So that could just be written as y. And then the last piece, 4 divided by 2 is 2. And I already have my negative sign, so I'm not worried about negative 4 divided by 2. And then x divided by x, those x's reduce out. And so this would be the factorization for this polynomial. Let's look at a couple more. So this first one here has a 4, and 4 is like 2 times 2, and then I have an x squared, so that's like x times x, and a y squared, and so that's y times y. For the 16, well, 16 can break down a lot, so I'm going to make like a factor tree for 16 real quick here. 16 is like 2 and 8, 8 is like 2 and 4, 4 is like 2 and 2. So the prime factors are 2 and 2 and 2 and 2. So the 16 can be written as 2 times 2 times 2 times 2, and then we have times x times y. So this is the factorization for 16. So the greatest common factor is that they each have 2 2's that we could take out. And you might be good at noticing that, oh, we could take a 4 out because 16 is divisible by 4. And then you don't necessarily have to do this entire factoring tree here. So 2 2's, that's the coefficient's greatest common factor, which is a 4. And then we look for letters that they have in common. This one has x and x, and this has a single x. So we can take a single x out of each one. We can also take a single y. And so the GCF is going to be 4xy. And so we're thinking about the pieces here. We have a 4x squared y squared plus a 16xy, and we're going to divide each piece by the GCF. We're going to write the GCF out front for the answer, and we're going to have 2 terms inside separated by a plus sign because there was 2 terms separated by a plus sign at the beginning. 4 divided by 4 reduces to 1. For the x's, there are more on top. There is 1 more on top. For the y's, there are more on top, 1 more on top. So that just leaves us with xy. For the second term, 16 divided by 4 is 4, and the x's are going to cancel, and the y's are going to cancel, and there's no letters. So the answer is 4xy parenthesis xy plus 4 for our factored form. Here I have a trinomial. The front has a 2, and the factors of 2 are just 2. And then it has x cubed, so x times x times x. The second piece has an 8, and 8, if you think of the factors of 8, is like 2 and 4, 2 and 2. So it does have 2 times 2 times 2 times x for that piece there. And then for the 6, 6 is like having 2 times 3 times x for its factors. So to find our GCF, I can take a 2 out of each one, but that is the highest number I could divide out of all 3. Next, you can only take the lowest amount of x's. So if you look, this has 3, this has 2, this has 1. So you're going to take the 1x out of each. And the reason is you can't take more than any one of them has. So I can't take 3 when I only have 2, and especially when I only have 1 here. So you can only take 1x out of each one. So for this example, the GCF is going to be 2x. So we're going to be taking our expression and we're going to divide each piece by 2x. So we're dividing by 2x, dividing by 2x, dividing by 2x. Our answer will have the GCF, the 2x out front. We're going to have 3 pieces. The first 2 are separated by a minus sign. The second 2 are separated by a plus sign. And this is because I'm not dividing out a negative. If the front number had a negative, then we might be dividing out a negative, and it might change the signs, and you just kind of have to watch for that. So 2 divided by 2 reduces to 1, and then for the x's, x cubed divided by x, essentially we're taking 1x out, and as you can see from our factorization back here, there's just x squared left. So honestly, for this division part of the problem, if you look back at the things that we did not circle, The things we did not circle are what are left. So the first term, what's left is the x times x, or the x squared. The second term, we're left with 2 times 2 and an x, and that's 4x. And if you do this division, you will get there as well. For the third term, the only thing that wasn't circled was the 3, and we are left with a 3 there. So there's a couple of ways to think about it. If you're writing out your factorization and circling the GCFs, you can just look at what was left, combine those pieces, and then you'll have that expression for that term. And then there's the answer for that one. Last one here is binomial. And I do have a negative on these. So they each have a negative 1 as part of the factors. So negative 1 times 2 times 3 would be how I would factor this negative 6. And then I have x squared, that's like x times x. For this negative 3 here, we have a negative 1 times 3, essentially. So if I'm going to factor out a negative 1 out of each, and a 3, because they did both have a 3, that's going to be my GCF. So my GCF is a negative 3. So I'm dividing out a negative 3 out of each piece. Now, for the second part here, notice that everything was circled, and there's really nothing left. You don't want to put a 0 for that. Where back here, we were just like simplifying what was left. If everything is being circled, you're left with a 1 there. So I'm going to show the division so that we can understand what's happening. So we have negative 6x squared, and we're dividing by a negative 3 because our GCF is a negative 3. And then we have a negative 3 divided by a negative 3 because, again, GCF is a negative 3. Negative 6 divided by a negative 3 is a positive 2. And then we didn't take any x's out, so we just have 2x squared there for the first term. And then the second term, negative 3 divided by negative 3, will get a positive 1. So the second term in the parentheses is a plus 1. And here is our answer for the factored form.